I'm Ryan Emberling, and welcome to Cuttle Code Tutorials, where you can learn full-stack web development using cuttle.cards, the open-source full-stack web application for playing the deepest card game under the sea. Today we're going to learn about WebSockets. We'll talk about why WebSockets are useful, what essential features they consist of, and how you can work with WebSockets using sails.js, using the example of Cuttle. So, why are WebSockets useful? Well, web applications generally consist of a server and different clients that interact with the server, and clients can make requests to the server, and then the server will respond with data or files depending on the specifics of the request. But what if you have a web application like Cuttle, where when one client makes a request, another client might need to be notified about it? For example, if the first client is creating a game and everybody on the site needs to know that there's a new game available, or if the two clients are together playing a game and the first client makes a move, and now we need to alert both players of the resulting update. So WebSockets essentially consist of, first and foremost, the ability to create a room on the server, and this is a group that you can put sockets into, and then to have different clients join the rooms that you create, which groups the client sockets together so that you can broadcast events to them. So then the server can send an event to a room, which will be broadcasted to every client socket that has been allocated to that room. And lastly, the clients need a way of handling the events that they receive so that they can know which event happened as well as what data goes with the event. So in sails.js, you can create and join rooms together with this sails.sockets.join function, which is globally available inside your controllers. And this takes two arguments. The first is a requesting socket, and the second is the string name of the socket room that you want to add the requesting socket to. And this combines joining and creating, because in this case, if the game list socket room doesn't yet exist, then Sails will create a socket room with that name, and then it will add the requesting socket to that room. So after you've grouped together some sockets in a room, you can broadcast an event with sails.sockets.broadcast. Again, this is server-side code, and that takes three arguments. The first is which socket room you want to announce an event to as a string. The second is the string name of the event that you want to broadcast. And the third is the plain old JavaScript object with the data that is the payload for the event. And then on the client side, you can refer to the Sails socket client with this IO instance. So the io.socket.on method takes two arguments. The first is the string name of the event. So this is the same event name that was sent in the broadcast method. And the second argument is a callback function, which takes a single parameter, and that is the payload, the data that was sent with the broadcast method. So this game created is the second argument of broadcast, and the event data is the third argument of broadcast, the payload. Okay, so that was sort of a low-level look at the basic implementation of sockets. But Sails also has this notion of associating sockets together with database records in a concept that's called resourceful pub/sub. And effectively, the idea is to make WebSocket rooms out of database IDs for specific model types. So in this case, a game, and every model, like the game in Cuttle, has a subscribe method, which takes a requesting socket and then a list of database IDs of games that you want to subscribe to, essentially. And this is really useful for an application like Cuttle or many others, where the organizing principle, the thing that connects the different sockets together, is that they're all paying attention to a specific database record. In this case, two different players, for example, playing the same game. And then there's this corresponding server-side method on every model, in this case the game as well, .publish, which takes an array of which game IDs you want to announce an event to, and then the payload. And notice that it doesn't have an event name, unlike the broadcast method, and that's because it uses the model name, in this case game, as the event name on the server side. And so you can structure your payload data to include whatever extra information is necessary. Like in this case, I'm having a verb which says that the update, or the Event is an update on the game, and the data includes the specific change as a string name, in addition to a full game object that's used for rendering. So then on the client side, we can use the same io.socket.on method, which allows us to handle, in this case, a game event that comes through the socket. And when that happens, we have this event data object, which has the same shape as the payload that we saw from the publish method here. So that is the fundamentals of WebSockets and how you can work with them using sails.js in the Cuttle ecosystem as an example. Thank you for watching this Cuttle code tutorial. If you liked this, please consider liking and subscribing for more full stack web development tech tips. I'll see you next time.